Hey, Donovan Keith here, and in this video I want to talk through how to make your own polygons from scratch. And we're going to go over things like creating a point positions array, constructing our own custom topology, maybe getting into things like custom UVs and assigning colors to different elements. This is going to be a technical deep dive, and this is specifically for people that are trying to create their own custom modeling tools, their own custom geometry primitives, where they are manipulating things at a very low level. This is not a video for artists, I wouldn't say, unless you also consider yourself a technical director or creative coder in addition to your sort of base artistic tool set. It's gonna be a little bit shaggy because this is a bit off the cuff, but I want to make sure that this information is out there, and I'm mostly going to keep this as a video that I can link people to if they have questions about specific things. So let's talk about some vocabulary in a new scene here, and we'll talk about what we're doing. So let's go into the front view here, and I'm going to take my doodle tool. So we're all fairly familiar with a polygon. So there's a few different kinds of polygons you probably know. You probably know a triangle. You probably know a quadrangle. You probably know something like a, let's see, a hexagon, which has got 6 sides. And you can even get, kind of wacky looking polygons that have more abstract shapes and quite a few sides. And you can even create a polygon like, say, this, which would be a rectangle with a triangular hole in it, let's say. And I'm just going to shade this in so we can kind of see that it's looking like this. Now, our polygons are defined by a few different things. There are points. Let me go with something lighter here, maybe a little bit bigger. Points on the corners of each of these sort of forms. And these points have a property, which is their position. So where are they in space? And let's sort of talk about this some more. So I'm just going to keep painting out some points here. In fact, these points are really kind of how you start constructing a polygon from scratch. So you don't actually start with a polygon. You start with a series of points. So let's build a triangle from scratch. So this triangle right over here. So I'm going to take this, and I'm going to add my first point. And then I'm going to add another point. And then I'm going to add another point over here. And let's go ahead and give these an index and a position. So let's say that this is point 0. It's the first point in our list. And its position, let's just pretend these are single units, is 3 on x. And y appears to be -2. This point right over here is -2 on y. On x, it looks like 6. And let's say that this is point number 1. This is our next point in our list. This point up here, let's say this is point number 2. And that's because we're using a 0-based index. This is really our third point. And its location is 0 on y, and it looks like 4.5 on x. Now, how would Cinema 4D store these point positions? Well, there is something called the positions data. I'm going to call this positions. And it's a table. And in this table are, right now, 3 entries. At the very far side over here, we have the index. 0, 1, 2. So we can call this ID x, and then we have our position. And our position here, 0 goes here, 1 goes here, 2 goes here. So this is 3, 2. This is 6, 3, minus 2. 6, minus 2. And this is 4.5, 0. And really, these positions are probably vector 3s. So there's actually a third component here, a z component, that just is currently 0. So that's how our positions get created and stored. Now, to turn this into a polygon, we need to create an association between these polygons right here, or these points. So I am now going to create, and maybe I'll take my doodle tool, and I'm actually going to erase some pretty big chunks here. So let me just erase these. And I'm really wishing I was using a pen and not a mouse for this, but oh well. Okay, so let's do this. So we've got our positions array. Now we want to turn this list of point positions into a polygon. So we want to draw a connection between these three right here. And we can say that a polygon, let's use, I don't know, orange, is right this sort of line right here, this sort of line right here, this sort of line right here. And I think, I'm not certain, but I think we want to use clockwise winding for polygons, and for splines, ironically, we want to use counterclockwise winding. So the winding is the order in which we draw these arrows. So we do this one, and then this is our next connection, and then this is our next connection. So we're going to go from 0 to 2 to 1 back to 0, right? So that's our polygon. So it's 0 to 2 to 1, and then because these are, so 0 to 1, and it's just sort of implied that it's going to loop back, right, to close. So we don't actually have to include that last one. So this is our, let's call this polygon 0. So polygon 0 looks like this, and so we've got the ID, so the index for the polygon, and then we've got the point indexes. And these refer to these indexes down here. But it's actually a little bit trickier than what we've made out right here. What happens when we want to add another polygon? Well, that next polygon, I'm going to sort of go with this sort of purpley color again. Let's say it's over here is the point. And now we want to add another polygon. And let's go over to this sort of orange color. Again, I'm going to start down here. I'm going to go up to this point, over to this point right here. And let's also define what this point is. So this point is point 0, 1, 2. This is a new point, so this is going to be 3. And this has got a position of 2 on x and 0 on y, and I'll add in z as well as 0. And so this right here, this table, let's just imagine now that there's this third entry. This table is sort of continuing, and now we've got 2, 0, 0. So this is our positions array. For this next polygon, we need to define this somehow. So now this is going to be polygon 1. This is polygon 0, right? We talked about that. Polygon 1 starts at point 0, goes to point 3, right? So we're referring to it by its index, not by its position, its index, and then goes to point 2. So that's our next polygon. Now, how does Cinema 4D actually store this data? How does it store these positions, the polygons? So polygon topology is stored in a very particular way. There's 3 arrays. One of them is points, is what it calls it. And the points is an array of every single point or every single sort of reference to a particular position index, right? So we can also call these vertices, is referencing one of these indexes down here in sequence. So it's 0, 2, 1, 0, 3, 2, 0, 3, excuse me, 0, 2, 1, 0, 3, 2. Now, this is just one long string, and we have to somehow chunk this up into separate polygons. And those polygons are called, or something that sort of feels like a polygon is called an outline. So the outline, it sort of controls how big each of these little chunks is. So we're going to take our points and we're going to chunk it up. I'm just going to draw sort of like invisible lines here for where our chunks are. This is 1, 2, 3 elements. So the first outline is 3 elements. The next is 1, 2, 3 elements long. That's 3 elements long. That is how we get our outline. So this data structure with an index and point indexes, this doesn't really exist at the low level. It's a helpful way of thinking about our polygons, but they're actually stored as a series of like an unbroken list of every single point in order. And the point is a reference to a particular position in space. And then the outline here is saying how to take that sort of very long list of indexes, of position indexes, and to chunk them up into different outlines. Now, this is all fairly intuitive so far. It gets a little bit more slippery or a little bit more confusing when we get to something like this, where we've got a polygon like so, with a triangle sort of cut out of it like so. So this one, let's say, is, so we were at 0, 1, point, position 2, position 3. So this is 4, 5, 6, 7, 8, 9, 10. And so let's just imagine we've extended this positions array to, let's just draw in 10 right here. And 10 is at 0.5 on x, and it's minus 0.5 on y, and it's 0 on z. So now that's one of them, and then we've got this other triangle here. So we need to extend points. Running out of space. So we're going to extend points. So points continues. So 0, 3, 2 continues. Now we want to draw these connections, I believe, in clockwise order. And then this internal section, I believe we want to do in counterclockwise order in order to create those holes. So let's start at 4 and continue. So it goes 4, 7, 6, 5. Now we're doing this sort of intersection. And that is, let's say, 8, 10, 9. And now we also have to chunk up our outlines. Let's continue our outlines. So I'm just going to continue this. So our first outline, this sort of rectangle on the outside, goes to here. So it's 4 wide, 1, 2, 3, 4 elements wide. And this internal section here is 3, because it's 3 edges, or 3 vertices, 3. And now here's our outline. Now the problem is, this is one whole polygon, right? It's solid. So how do we represent this outline has a correspondence to this outline, and they make one thing? And for that, there's something called groups. So I'm going to add a new section here. Let's call it groups. And these groups, I'm going to make a new table for them. They go like so. Each polygon is made up of one or more outlines. So this first one is this outline right here. So it's one group long. This next polygon, this guy right here, is one outline long. So there we go. This next one, this sort of like compound polygon with a hole, is the outside, this guy, plus it's also the inside, this one right here. So that's 1, 2. So this is our groups. And those are our key data tables, the key parts of what's called our polygon topology that we need to build up. So that's been our sort of whiteboard explanation. Let's go ahead and build this from scratch in Scene Notes. So I'm going to go ahead and create a new project. Let's call it Nodes Mesh. And I'm going to go to Nodes. And then in my Nodes Mesh, we are going to build up our own polygon from scratch. But let's first add a polygon. Connect this to the output. And I'm going to do -z like this so that we can see it. And I'm going to make it, let's say, 1 by 1. So the units are a little bit more manageable. And then I'm going to right-click on the geometry here and choose Data Inspector. And inside of here, we're going to see a few different things. We've got our points list, and we've got a list of polygons that each point sort of corresponds to. This compact list is a helpful display, but the detailed list is actually a representation of the data structure sort of underneath everything. So for points, we have an array called point, pt, and this includes every one of our positions. So 0 is -0.5, -0.5. So it's this one over here. 1 is -0.5, 0.5. That's this one over here. 2, 3, and so forth. And then the polygon attributes, the first polygon is polygon 0 is 0, 1, 2, 3, like so. That all works. Let's take our polygon and just increase the number of segments and take a look at the points again. I'm going to take a look at this with garage shading lines. So we've got 4 polygons now. If we look at our points, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 points, which we see here. It's not a unique point per polygon corner. Those are sometimes shared, right? So the points are the same. If you go to our polygon attributes, we see that polygon 0, let's go ahead and turn on our point indexes in the viewport. Polygon 0 is 0, 4, 8, 7. So yeah, it's clockwise. Polygon 1 is 7, 8, 6, 3. 7, 8, 6, 3. Polygon 2 is 4, 1, 5, 8. And polygon 3 is 8, 5, 2, 6. So some of these polygons are sharing a point. Let's now take a look at our UVs, which are going to be similar but different. And the UVs have got a list of points that is 9 long. That feels correct. And then we've got this same sort of divvying things up. All right. So how do we build this from scratch? Let's build our own polygon. Let's choose to poly topology set. The polygons topology set is going to help us sort of stitch together these different things. And there's another node that we need, which is geoposition, or geometry property set positions. So here we need to input our topology, and we need to feed it an array of positions. And from this, we will get a geometry. So the first thing we need is an array of positions. Let's just build a triangle. So I'm going to add a build array. And this is going to let me build up a list of point positions. So I'm going to choose vector. Actually, let's do a quad. I think that'll be more fun. So the 0th point, we're going to put kind of like, we're going to do kind of this, right? So the first point is, let's call it the 0, lower left. That's 0, 0, 0. 1, upper left. 0, 1, great. 2, upper right. That is going to be 1 over, 1 up. And 3, lower right is going to be 1, 0. So here we've got our point positions. So here I can take my point positions, stick it into here, and we now see that we've got 4 points that are being generated, but there's no polygons per se. Now, to build our polygons, we need a few arrays here. For the points array, I'm going to build an array of integers. And these integers are my point indexes. So a point, you can also think of these, I guess, as our vertexes, right? The association between a given kind of point in space and a given position in space. So this is 0, lower left, or here. Let's just punch in the numbers. So 0, 1, 2, 3. 0, 1, 2, 3. And output that for our points. Now we need to build another array of outlines. So we've done our points array. We've done our positions array. Our outlines array is talking about how many points are there in a given outline. And so now we need to build an array. 0 outline. We're going to call this outline 0. And here we should have 1, 2, 3, 4 points in this outline. And now it is turned into a polygon. Then if we want to be really good, we will duplicate this and we will say group 1 should have 1 outline per group. And this is the somewhat painful process for creating our own custom topology. Now, let's say we want to build a triangle. I'm going to add some more points here. 1, 2, 3. Let's call this point 4. T lower left. Point 5 is T top. And 6 will be T lower right. And I'm just going to put them in like a third over. So 0.33, 0.33. And then the top is going to be 0.5, 0.66. And the lower right is going to be 0.67, and the y will be 0.33, something like this. So now we've got these extra point positions. We need to add those 2, 3. So 3, 4, 5, 6. We need to add a new outline here for that triangle. 1, 2, 3. And right now we've got a triangle, a second triangle, that's being built right on top of the first. We've got an option here. We can add an additional group with one element, and it's going to give us the same thing. It's going to be a separate triangle. Or we could say that the group is 2. And it's going to punch a hole here for that triangle inside. So this is how we construct a topology. The topology has got our point positions. It has got our I'm going to call these vertexes. Then we've got our outlines. And we've got our groups. And the combination of all of these things is our polygon object. Now, if we want to do something like assign a color here, that gets interesting as well. That's also using a topology. I'm going to build a simple you know what? Let's leave this here, and we might pick up and talk about how to create custom topologies for things like colors, normals, and so forth moving forward. But I think this is enough for one video. Again, we've covered the basics of polygon topology in Cinema 4D. You've got a few key things. You've got a list of point positions. You've built a points, or what I like to call a vertexes array, which is a sequence of references to these point positions, a series of outlines, which help to construct your polygons, and then groups if your polygons are made of multiple outlines. And all of this is controlled with Polygons topology set to build our topology, and the key thing here is the set positions, which is expecting a topology.